Hello, everyone, and welcome to Handmade Hero, where we code complete game live on stream. We are at the immediate moment about to start doing some Handmade Hero programming, but I just wanted to mention for people who watched yesterday's attempt to build TensorFlow, we left it running so it could just run because we know that TensorFlow takes hours to build, and it did, but it eventually finished. And if you run it again now, which is I just did, it does complete. So, I mean, I don't know that we really built TensorFlow perfectly, but it sort of works. So now if we build it, we tried doing a rebuild. It took 48 seconds to not do anything, but tell us it was built. And now if you do it hot, it only takes 4 seconds to not build anything, which, by the way, is the time it takes to completely build Handmade Hero from start to finish. But hey, it works. So now we have a TensorFlow build. And so at some point, I think we might play around with that. I think a fun thing to do would be to go take one of their kernels and show how if you just rewrite it in C, it's probably like 20 lines of code and compiles in, instantaneously. Because it was so hilarious how bad the TensorFlow build was. I mean, I've never seen a build that bad before in my life. I mean, I'm sure there are builds that are worse than that somewhere, but it's amazing to me that it's amazing to me that trillion-dollar companies, I mean, it just goes to show you that what we do with programming is, I would say it's largely just mostly about honor, I guess, to program well, because it's pretty clear that you can have no idea what you're doing and still have a trillion-dollar company, right? And TensorFlow is the proof of that. There just isn't competition out there, right? So mostly your success as a company is about things that have nothing to do with programming, because if it was about programming, there's no way this would ever fly. All right, so let's go ahead and get started on regular Handmade Hero. Where we left off before is we were sort of at the point where we were like, look, if we want to do some reasonable, lighting, we were trying to play around with that and seeing what we could do to get it to work. And it's a very big investment, right? And we played around with some things. We weren't really able to do anything particularly simple that would allow us to get reasonable lighting going on. So we have a fairly complex set of things in there now, but they're not really quite what they need to be. You can see that our interpolation works pretty well. And if we just have, a basic single light source and stuff, surprisingly, we get really good results out of that. But, we don't have a really solid plan for how we extend past that. And there's just a lot of work that has to be done in order to get there. So I don't know exactly how we want to go forwards with this. We have really two things that we could do. Because we do have at least now a sense of how the lighting actually is working. And if you look at how it works right now, where I'm hopping around with this little sort of circular light source in the system now, we could just kind of tune that out and say that's what we're going to work with for lighting for now, is a few little circular light sources, and then come back to lighting kind of at the end of things and try to tweak that and get that more proper when we're a little bit further down, right? By the way, is this work? So it's worth noting that I don't think we get sound from this machine at the moment, which I suppose isn't a problem, but I should make sure that works to the streaming machine, because at some point when we're doing work on that sort of stuff, we should probably make sure we can play sounds from this machine onto the stream, because right now, like, that's playing a little sound effect, but it's not coming out on the audio for the stream, so that's a little bit busted. So I guess what I would say is, I think maybe what I'll do, and again, I'm not 100% sure what I want to do here, but I think maybe what I'll do is I'll spend a few weeks going over the lighting with a fine-tooth comb, putting in what I think should roughly be, the lighting for a reasonable working solution, just because I would like to do that. And then we'll just take whatever is at the end of that, and we'll say that's going to be our lighting for all the development process, and we're not going to go any further with it, right? And then when we're done with that, we'll move on, and we'll finish the game that way. And if we want to, at the end, we can come back and rat hole on lighting for as long as we want if we want to keep improving the quality of it. Because again, lighting is just is one of the most complicated things you can possibly do in graphics, is any kind of realistic lighting, or even just propagation, any kind of secondary bounce lighting. And so I would like to limit the amount of time we spend on that. And there's other stuff that we have to work on anyway. We want to finish some of the entity stuff, and we want to finish, we want to make sure we're grabbing regions appropriately. Like right now, we're sort of not. You can see that that's not getting the stuff that's down there. We should be picking that up, and it's not being picked up until we move a little bit forward, right? So there's some things like with bounding where the lights are calculated and which things are pulled into the active set that we do want to get a little bit more tightened up for development as well, because we'd like this to be, it's pretty close to just being fully presentable as a game, right, in terms of the presentation qualities up there. And if we just finish up some of these things, then we have a fully presentable game that we wouldn't really have to worry about the presentation quality until we basically are finished, right? All right, so looking over the lighting, we had a couple different aspects of it that needed to really get addressed. So one of the main things that we're not doing right now that we kind of need to do is we don't have really any concept of what the lighting values actually are. So that was an issue that we're going to have to address. And then we also have the problem of so when we're actually doing the lighting computations, we don't really have a solid idea of what's going on there either. Because when we're actually sampling the lighting points, we don't actually have anything. We don't actually have any way of getting that to work properly. At the moment, it's buggy and weird. So we have to kind of get the raycasting stuff working properly as well. What we did verify, at least to a first approximation, is that our raycaster is working properly. At least we did some rudimentary debugging of that, so that it at least appears that our raycast properly can tell when there's interference and when there's not, and so on, right? So that seemed to be working. And so I think we can more or less assume that that is correct, right? And so, we think this part's working okay, and we think that the raycast is working okay, but the light summation is not really, and the light persistence from frame to frame, that sort of stuff isn't really working. And so we need to kind of get those into a rudimentary state of working so that we can at least know that system is okay, and go from there, right? Okay. So what we need to do now is switch over to the other. Well, so I guess there's two things we can do now. One thing is we could leave it the way it is at the moment. So right now, we are doing a single light that you can kind of see here is moving around the player. What we could do, and maybe what we should do, is we could figure out how we want this to work in terms of what the lighting values actually refer to. So right now, we just have arbitrary floats in there that are just saying okay, at some point we're going to map 0 to 1 to a lighting value, but we never really had any idea of what that means, right? So we don't actually have any correspondence to the real world of what the lighting values actually are. And furthermore, we don't have any exposure function. So at the end, we don't actually try to map these light values into any kind of a space that makes sense, right? We don't have the idea that there's values that go into lighting that eventually get resolved in some way, right? So one of the things that we probably want to do is get that working properly so that we can at least visualize these things well. And the other thing that I'd like to do there is have a way of visualizing them in some way that we can use that allows us to see the lighting without any weirdness, so that we can actually see maybe blue is no light, green is in the sweet spot of relatively what we would expect lighting to be, and then red is as bright as the sun or something. You know what I mean? Something that would allow us to really have a better handle on what's going on there. All right, so let's go ahead and try to go further down all of these lines. In order to get us warmed up, I'm going to say let's do something we've been meaning to do for a very long time, which is let's just make the renderer hot reloadable so that we can, anytime we want, change anything in the renderer and it'll just automatically rerun. So if we go into Win32 Handmade.cpp, what you can see here is that when we're doing stuff, we actually have the ability to load multiple DLLs here, and we know that because we load a DLL for the game and a DLL for the renderer, right? So if we take a look at the DLLs for the game, for example, you can see this stuff happening here. So you can see it looking for a Handmade DLL there, right? And it does this sort of like looking for a lock file and figuring out what it should do with that to determine when it should reload the game. But then there's also like a renderer, and that renderer, I don't actually remember exactly how we link that in, but I think maybe it's just hard linked in at the moment. I guess I could be wrong about that. Yeah. So as you can see here, like we kind of hard link in a renderer there, right? So these are all like bringing that, like the renderer code in here. And I don't know if we ever actually load it as a DLL. We might. Let's take a look. I don't remember if we actually did that part or not. Let's see. Dsound. No, it doesn't look like it. It doesn't look like it. So if you go over here to the build directory and we look at what we've got, you can see us building the Handmade OpenGL DLL. Oh, you know what? Yes, we do. We just load it somewhere else. Forgot about that. So I believe what happens is this right here, right? So this stuff right here, right? So here's the call that we actually make into the renderer to get it started, right? So I believe what happens is the renderer loading there is just... do this. The renderer loading there is just calling getProcAddress to initialize the renderer. So it's like actually right here, it's this that actually does it. And you can see that it says like, oh, okay, I'm going to load the DLL through here, and then I'm going to initialize it, right? So I think all we really want to do here is say, okay, let's move this stuff off into, let's like make a common system for having our DLLs be reloaded so that this one can also get reloaded anytime that it changes. So if we look at like Handmade, if the Win32 Handmade code, what we could do is pull out the code that actually does that reloading so that we can use it for other things. And if you look at what's going on here, you can see we have this Win32 game code thing, and it's got the game code DLL, the file time of the DLL so we know when it changed. It has the functions that are used by that so that it can be called into, and then it has an is valid, right? Which basically says like, were we actually able to load one of these things? And what you can sort of see here is like, this is actually pretty generic. Like the only difference between this and this is which of these functions are there, like which things you actually call into. So if we wanted to, we could sort of pull this out into something that, made maybe a little bit more sense. We could pull this out and these would all stay the same and only these callbacks here would change, right? So if we wanted to, you could imagine we had something like Win32 loaded code or something, or Win32, I don't know what we want to call it. Win32 something. Win32 code stuff. Win32... I don't know. I'm going to call it Win32 loaded code. That's just what we're going to call it. And immediately we could say, well, we know that this, right, would be, there we go. We know that this would be everything that we need to do the hot reloading part of this, and this is the only part that really changes, right? And what we could do is we could make even this part do roughly what we want it to do because we could consider these particular things here where we have like these callback pieces. We could sort of try to make those be a little bit more generic, right? So, for example, you can imagine if we just did something, I don't know, like say this. We could just say, look, this thing's going to load some functions and it has some pointers here, and then we're just going to say which ones they are for anyone who actually loads it. So we could do something like that, right, where we would use it in this way. And then you would just point whatever this table is here, you would point it at this and use it in your own way, right? And the other way we could do this is just make this thing be a utility, and that utility just sits at the top of anyone who wants to actually do this, right? And so, you know, maybe this is a better way to go about it. I don't know, but here's just, I'll sketch it out. So let's suppose we have this as Win32 loaded code here. And we just say, look, this is the loaded part of this. And then the other part lives down here. And so then later, if we want to, we can make another one of these, which is like Win32 renderer code. And we just say, look, there's a loaded on top of that. And this part here, right, gets the load call, right? You know what I'm saying? And so I guess what this would look like is this part that's at the top, you know, you're responsible for calling an update function on it anytime you want it to check. And then you load what you want to load out of it anytime you get to a point when and you think you would need to, right? So that would be relatively straightforward to do. And, you know, you could imagine doing it even kind of more ridiculous than that. And there's a couple of different things we could do here that would kind of be interesting too. So if you think about this part of the code, right, one of the things that we did that maybe wasn't the smartest thing is we could also just say, what if there's only like one thing that you do here, which is sort of a like initialize. I could imagine doing this so that there's really just one thing. So there's just like something like this. In fact, that seems like probably the right thing to do. I'm going to go ahead and say it is. So bear with me for a second. So let's suppose we had a thing that's basically like a Win32 loaded code entry point. And yeah. I think this might be the right thing to do. So bear with me here, and I'm just going to sketch out what I think this might look like. So let's suppose we just made a thing that's like a loaded code entry point, right? And what this thing is going to do is it's going to have some kind of a B32X return, right? And that's going to say whether or not it was able to consider itself valid. So that's where that will go. And when you do this thing, what you pass in is some kind of a like, code table, right? Or a function table. And it's going to fill that out for you. And it gets passed the module to load from. So whatever the external code did, it's going to get that passed in, right? And we may never even need to actually store this. This may actually just be done in line. But anyway, point being, this is what it would look like. And then we would have Win32 loaded code entry point. So what we would basically do is say, all right, you're going to call one of these. And so really what there is there's a Win32, so this Win32 game code thing here, for example, right, is really just going to have a function table in it. And so it could be Win32, you know, function table or whatever. 32 game function table. Right? And then the same thing would kind of be true here, right? So you would end up with a function table that, you know, Win32 render function table, right? That seems better to me because then these all look exactly the same for all intents and purposes. And so we could probably just get rid of them and we can just have the loaded code thing be the only thing that we actually need, right? And so I think I'm going to try sketching out how that works and doing it this way. I think that would be better, right? And it also gives us the opportunity to perhaps make all of our code be hot reloadable, even the platform code, because at that point we could sort of extend it forward. So I'm going to play around with this a little bit, and I'm going to see what happens if we go down this route. So the first thing I'm going to do is say, what if I get rid of this? So I have a function table and a loaded code thing, and I know these two things work together. Right. And what is just working through the compile errors, I'm going to sort of massage the code that it's in there currently to see how I want this to work out, right? And so if you look at this Win32 load game code stuff, right, where it's going to load in the DLL here, what I'm basically saying is, all right, I want that function table to get initialized, and well, I'm thinking this can even be automated one step further than that. Yeah, okay. So let me go even one step further than that. So we probably don't even need to do this manually, right? So what you can probably do here, if you want to, is this could actually also probably just be a table. And since these are just function pointers that go in order, we can probably just literally say, like, all right, there's going to be we can probably just pass this with it and it would automatically update the function table for us because everything's just going to be a series of get proc address calls, right? So we can actually just do that. Honestly, that probably just works, right? All right. So let me just go ahead and do that. Again, here's where metaprogramming would be nice because you wouldn't have to type this twice, but, C++, they don't know what they're doing over there. All right, so here we go. In this Win32 load game code here, where it returns a game code, all I'm going to really change that to be is something where we have, where we pass it the loaded code thing that we want to use. So like here we would say, all right, here's your loaded, and then this function table here is just going to be like you pass it what you wanted to do with these three things. And we can bundle those together like Win32 function table definition or something like that. And we just say like, here's the functions that we're going to write, here's the function count, and here's the function names. Right? Something like this. So you would say, all right, here's the loaded code that we're working with. And, I guess I could even expand it a little bit further and say, well, or we could even put this in there, right? Right? So I guess in that sense, we could just say, okay, you know what? Let's make the loaded code structure just do that for us. Even better. So you can pass one of these, right? Here's the loaded code thing we're going to use. And it's not going to do that anymore. And we're going to do this. So then we say, all right, Win32 load game code. Let's go ahead and load this up. And the way we're going to do that is that all of this stuff that normally happens here, right, is actually going to just fill it out into this loaded function. So in here we do get file attributes, and we have the lock file name, get file info standard. All that stuff will be the same, but now we're going to do it in here, right? I'm also going to have this not include any reference to game code exactly, right? So you can see here, these are the actual names of this, I guess. So I guess we actually want to do these. Okay. Like so. And so here we're just going to say, all right, we want to load these things. We're going to load them off of the DLL, like so, right? And you can see this starting to collapse down. So now we'll have those names over here. We're sort of saying that the is valid is actually going to be something that either all of them work or they don't. So, you know, this shouldn't say either of the callbacks. And we'll just say, like, the callbacks can be 0. You must check before calling. Or check the is valid Boolean in Win32 loaded code. Okay. So now we're okay. I don't know what that's about exactly, but I guess we're just doing some kind of checking there. Anyway, so here's a bunch of nonsense, and we're doing some reloading here. I guess that's about whether or not we don't want to pile up too many files, I guess, or something. Anyway, so we're going to load the DLL in, and then instead of doing each of these manually, what we're going to do is we're going to loop over the function index, right? Because now we know we've got... this isn't actually called result, I suppose. It's called loaded. Also, this temp DLL number shouldn't really be in the state, should it? It should be in the loaded, I would think. So I'm also going to do this. I think that makes more sense. Yeah. And that's just looking for a bunch of different versions of the same name because we don't know which random version it output, right? If I remember correctly, it was because it's because Visual Studio is terrible and locks the PDB, so you can't actually. We had to make it so that it output different ones, I think. Oh well, and also there's another reason for it. It's because we wanted to keep the old DLL loaded. Yeah. So basically, I guess it's not Visual Studio. It's actually just Windows. Because on Linux, you would just have an inode for that, so it wouldn't matter, right? Yeah. Okay. So anyway, we'll probably want this because this temp DLL number thing is going to have to be something that we manage more carefully. And we'll probably have to do that per DLL. So we'll put that in there. Then we'll have loaded like so. And the temp DLL name is there, which is what we want. And then we go through however many of these there are, so however many functions there are going to be. And each one of them gets loaded. So we're going to look, this right here actually is a pointer to a pointer. So for each of these, we're going to say, all right, whatever the nth one of these things is, right, we're going to do a get proc address on it, and we're going to pass the name of the function we're trying to load, and that's going to load it, right? And for each one of those, we'll also know, we'll just say like, all right, the isValid flag is going to start off equaling true, but if any of these don't work, oops. Right? There we go. If any of these don't work, so if we do a get proc address on one of these and it doesn't work, so it'd basically be this, right? then we know that the, oops, and that's not result is valid, I guess it's this. Then we know that it's actually not valid anymore, and the game should just be like, nah, not gonna work, right? So I think that's all we really need to do. And what we wanted to do here, I guess, is clear this. So I guess what we want to do is have another one of these loops over here, which basically says, and I guess we don't really need to do a loop because we have a zero array call, right? So what we can actually do is just say, look, if it wasn't valid, so like if this was not, if that wasn't in the works, that wasn't in the mix, then we can just say clear out this table. So if we failed, if either we couldn't load the thing or whatever, then just set them to 0 so the game kind of stops at that point, and there's an error. And maybe we want to display an error here, I don't know. Hard to say. Anyway, so that would do all of our loading for us, right? And this will load anything now. So we can prep these for arbitrary sets of code, and it will just produce what we want, right? And we don't have to do anything else. So the only thing we had to load there, or change there, I guess, is in the state we got this temp DLL number thing, and that's now because we might load many DLLs, and maybe multiple of those DLLs actually would need to know things, like which one of them they were loading, just like the other one did. So we probably need that to be, per DLL. So we're going to have to leave it like that. And, oops. And so that will load everything for us, and now we just have to change the other code to use this more effectively. So now if we look down here and we've got unload game code, which is the complement of this, right? Really all we need to do there is say, hey, actually, we want to make this work with anything. So what we would do is just say, if you pass us whatever the loaded thing is here, we're going to go ahead and tell you that it's unloaded. So we're going to do this. We're not going to free it because we don't do that anymore. We just let those things pile up. We're going to say that it's not valid anymore, and then we're going to do this. Right? And we could, if we wanted to, and I don't know that we do, but we could say that, like, hey, if we have a load and unload, maybe what we'll do is just say this here. I don't know, right? It's a thought. Okay. So now here's the people who actually use this stuff. And if we take a look here, we've got this Win32 loaded code that we might want to do for like the game code, for example. And what we'd want to do now is just say Win32 load code, right? And we'd pass exactly the same things that we were passing before. All of this garbage, right? And now we just need to pass like this thing to have it initialize. And we need to have specified this to be something that actually has some state, right? So we want to actually say, okay, the function count is going to be equal to, however, like this is our functions, right? So the function count is going to be equal to however many functions we actually have in our table. We know we want an actual game code thing that's like this, right? This has the functions in it. So we're just going to say, all right, point the functions at this game structure, right? Because that's what that's going to be. So fill that thing out for us. And then, get the names going in there. Now when we load the code, it should just run, right? We shouldn't have any problem with that, right? It should just be able to load it. Using that information. And then, yeah, so in here, where we do the compare file time to see whether the executable needs to be reloaded. Also, not sure what this is about, or why it's turned off. Oh, I guess this will restart the entire thing, but we don't do that anymore. You can see us doing a Win32 load here. Here's an unload and a load. And so we would want to do those again, right? And so a couple things about that. If you now start to look at what's going on, you can see that those are passed frequently and they don't change, right? So what we probably want to do here is actually weld those in. So let's go just do that really quickly too. So here at Win32 load code, the other thing that I'm not sure about is what is that state variable actually used for? Because we don't use the state variable anywhere here. So I don't actually know what Win32 build exi path name. What is that? What does it actually use the state for? So like all of this stuff should probably be just in the loaded code thing. Right? So I think this is actually not what we want anymore, right? I think like we want to just weld this together because, yeah, all of this stuff is kind of a little bit wrong. Yeah, so I think that stuff can just be put into the loaded code thing. So I think that's what we actually want. So let's also do that. So if I say that this is actually this, and in here we say we're going to do that, right? So there's our function now. And then instead of passing the state here, we're going to pass Win32 loaded code like so. Exe file name, state exe file name, all this garbage, right? I think, let me just double check. You look at what that's actually holding. There it is. Well, okay, so you know what? The only thing I would say is actually the no. Okay, that's just the path. So we don't actually, that will be the same for everything. So never mind, we can leave it like this. This won't change per loaded. That's just the path. That's just the path. So we're good. All right, so it's really only these things that we would need to actually weld in there because it's just redundant, right? So what we'd rather do is this. That, right? So that when we do a load, we don't have to pass anything new, right? So, excuse me. So in the loaded code thing, we can just say, all right, in here we just have two pointers. One is the full path and one is the lock full path. And then when we do a load code on here, we don't have to pass these anymore, right? Because we know that they actually are just pointing to something inside the struct itself. So we can say, all right, this is the full path and this is the lock path. Right? Okay. Keep going. This right here just needs to look at the game code. This here needs to look at the DLL last write time, but you can see that this whole procedure here this part now needs to be something you can just call to make your stuff do what it needs to do. So we want this to be kind of encapsulated into a little unit that we can just use. If you look at how we have to sort of stride this out, we want it in two pieces because some people need to call it in two stages. So like we want to grab this and this and kind of have them be separate pieces, right? So what we want to do is do a thing like, let's say this. Something like that, let's say. So, I don't know why I did that. So, you know, something where we say, look, let's check for a change and it'll return this. And that's just this right here. So this part where we're like, let's check for a code change, check for code change, is just this code, right? And it's going to take one of these Win32 loaded code things. And it needs to know the full path to the DLL, so this part right here, right? It needs to figure out what the last write time is for that thing. And then it needs to compare those two, right? So whatever the new DLL write time is and the old one, right? And the only thing that I'm not super clear on here is, I guess, so are we basically saying that thing just updates in place? I don't really know. Also, this should probably be that, right? So anyway, this is what we're going to do here, and that'll encapsulate this part into something we can reuse for everybody. So that. And then, like, we need something here where we can take this part, which is the unload and the retry set of things. So this needs to be, like... this needs to be updated in here. So I don't know what we're going to call this, but like reload. Like so. And that'll do. This reload, it'll do the try thing. It'll say, like, as long as this thing is not valid, we're going to try again. We're going to try a bunch of times to get it to load and see if we can. Right? And then we're going to, we're going to sleep on that. So if we grab these out now and we make this thing be, oops. And we make this thing be the loading off the game code. I guess this also has to do that. Then if I just drop these down back where we were doing Win32 low code, we should be good to go. Like that, right? I think. Seems plausible anyway. So let's go ahead and try to make that work. This right here, the only thing I'm a little confused about is this should take the DLLs write time. No, that's fine. That should just work. All right. Fix that. The state here, when it does Win32 load code, that's going to need this for sure. So we'll just pass that down. All right. So this is Win32 check for code change. This is Win32 reload code. And now, I think, is that it? Is that everything? I just accidentally deleted. Oh, we got one more thing. Full path. So this needs to be passed to the state there. Is it address of state? What is that? I don't know what that is. Where's Win32 load code? Where'd it go? Yeah, it's just state. All right, so let's just finish up the compilers and then let's see if it works at all. And from there, if it does work, we can, that. From there, if it does work, we can then move to the next step, which is putting more things through that path, which is what we want to ideally put everything through that path, I guess. All right. So here's Win32 load code. What is it saying? Assignment within conditional expression. Okay, yeah, I know I did that on purpose, but all right. Thank you, Mr. Compiler. So I guess we'll do this. If function, then assign it, else we're screwed, right? Reload code has to return a value. No, it doesn't. Like false, incorrect. But I think we're good now. All right, so all I really want to do now is just start putting more things from that system. And, I mean, hey, we at least know it worked once. So if I want it to verify that this works, in Handmade here, I need to do something, right? So what I would need to do here is figure out something I can make a change to that would immediately update itself. I assume in the world mode, for example, one thing I could do is change the debug light. So, because that would be obvious. So if we go in here and you can see like we've got this, maybe what I'll do is I'll make the debug light much higher up and verify that it actually changes what the lighting is. Yep. And then I'll go down here and change it back. So now it'll move it down again. And it is. All right. So we know that that code reloading is working because I just changed code on the fly and it worked just fine. And so now the thing is like, all right, can we get that to happen in the renderer as well, right? And also, if we wanted to now, we could make it push more things in there. So, you know, one thing we might want to do is make it so that actually there's just a Win32. We can make it so there's just a Win32 thing in general that reloads itself, so that all of the platform code is also hot reloadable. I mean, I don't know that we care because we probably, like most of the stuff, doesn't run every frame. So I'm not sure that there's much use to it because most of the stuff is like startup stuff and that you can't hot reload because it's already happened, right? So that may not make any sense, but at least the renderer, we definitely want to do that for. So I'm going to go ahead and take a look at what that would entail. So in here, if we said, you know, that this part, so the Win32 init default renderer, right? So that's coming from the renderer DLL. And if I want to, oops, nope, no, bad. So if I want to, I should be able to go to the renderer code here and redo how this is happening, right? So you can see this. I mean, really, this is just a case of just not calling this code, right? I mean, we can leave this code in here if we want to. But I mean, really, I think that's mostly all it is. So, you know, there's a global called, you know, Win32 render function names. And it's just that. right? And it knows that it's only got one of these things. So, you know, that would just work. So in the case where we want to use our own system now for this, which we do, I should be able to do exactly the same thing that I did with the other one. So this nonsense here, right? So I should be able to say, all right, if we want the renderer to do this as well, then back where it actually loads that up, and we kind of need to say what that file name would be here as well. So I guess again, I don't know. The reason that this code exists here at all is just so that people can not have to write that themselves out in their own thing. And I don't know that I really want to keep doing that. So what I might say is maybe this goes away, right? Maybe this goes away. And what we do here is say that this stuff here actually moves into the renderer test, right? So the renderer test itself is going to need to do this part of the code. Like in here where it loads the thing, which is who knows where. Right here, I guess? Yeah. So in here where it loads the thing, we would just say, yeah, so you have to do that yourself now. So if you want this stuff, that's on you, right? And so that code just goes in here. I don't know why this would be separate. Like, I don't know why. So let me just... Yeah. So that doesn't matter at all. So this part right here can just be welded together. It just looks like that. And that. Right? This goes away. And our renderer test should still work just fine now because it's just calling the same code it was calling. Yep. So this code should be fine. And now we just need, in our other side of things, we can just use this to create our own, you know, function table here, right? So inside Win32 Handmade, we're gonna do our own version so that we can hot load it instead of using the currently existing thing. So we're gonna have a Win32 renderer function table. And in fact, we could even put that in here and do this. All right. Okay. So now we can just yeah. So now we can just call the exact same calls we were calling before, and just point them at the renderer, and that should be the end of it. Now, there'll be a little more work involved because the renderer is not hot loadable at the moment because I don't think it knows. Like, we have to put in a thing that knows that when you're going to reload it, you have to call the function in it that's like, shut down the GL stuff and then restart it later, right? Because it has to recompile all its shaders and all that garbage, right? So we're going to have a thing that tells it to, like, redo stuff. But other than that, we should be okay. So we will have a little bit more work to do, but that's okay. We've got some time left in the stream, so it should be pretty reasonable, right? Off we go. Oh, and by the way, yeah, I know we can turn off the assign within conditional expression, but we don't want to, right? We already turn off lots of them. But that one, I think, is not a particularly good idea, right? So here's the warnings we thought were a good idea to turn off, and that one we wanted to keep. Okay, so moving along, let's go ahead and actually call this in Win32 Handmade here. And so that DLL, again, maybe we want that name to be standardized. I'm not sure we do, so I may not do that. What I may do is say, all right, we've got a compilation thing here. We probably need to do the same stuff as, like, we probably need to do literally this. And so we have, like, oops. We probably want to do the Handmade renderer test. Needs to have that. And what we probably want to do here is say, all right, this is the, like, OpenGL lock or whatever. And I think that's what we're looking at here. Now, the bummer here is that means that our build.bat probably gets a little more complicated because, again, we got to work around Windows, right? And so if you look at how we build the game, you can see here it's like, hey, it's going to do all this nonsense, right? Like waiting for this lock. And once the lock is done, it's going to delete it, right? And maybe, you know, since these things get built together, maybe what we could do here is actually reorganize this a little bit and say, all right, if the test bed went down here and the renderer is here, let's move that inside the lock, and then we only have to have one lock, right? So if I said, like, okay, here are the renderers, so in here we do, like, waiting for PDB lock, or we echo to the lock, right? And then we rebuild the renderers and the game, right? Something like that, I guess. Makes sense. So we do compile here of the renderer using the same technique. And in here, we look and you can see, like, we've got Handmade and then that pound random thing there, right? And the pound random on the PDB, So wait a minute. When we do this compile, I'm a little confused because that random number, I don't remember. I got to watch my own video to remember what kind of nonsense we did here. We're only specifying a random one for the PDB, but not for the DLL. So I guess that's because we move the DLL ourselves. Yeah. So that's because we move the DLL ourselves. Okay. So I guess what that means is that as long as the renderer just has an arbitrary nonsense PDB, we actually don't have to rename it, which is kind of nice. And if we put it inside this lock, then we don't need two locks either, right? So basically all we have to do here, I think, is just put this right there, right? And say that, all right, so Win32 Handmade OpenGL random PDB, and that should be fine. All of this should just work, I think. That way, the lock file name doesn't actually need to be different. So instead of this, that can just be, instead of game code lock, we can just have this be like called lock full path. Or code lock, right? And it can just get used for everything. Now we can choose to have more locks later if we need to by multiplexing that, right? But for now, we don't actually have to do that. We can just use one lock and everybody can share the same lock, right? So that seems good. So let's make that happen. And let's make this happen, right? So first, we're going to start by loading the renderer in a different way. So the way we're going to do that is just say, okay, instead of this code here, when we do a Win32 load code, we're going to have this called renderer code here. Right? And this is going to be like renderer code full path. And this right here is going to be like Win32 renderer function table names. And the actual functions themselves, I guess like we've only got one, right? Oops. And so then when we actually load this, that's supposed to be that, we should be able to just do like, hey, we loaded this renderer code, and so now we can actually just call like renderer dot load renderer. And I think that's it. So we've got a few compile errors here. Oh, and that's renderer. So this is renderer like functions or something. Looks like we also need to pass the window DC there. Handmade code, Win32 renderer test, no such file or directory. Right, can't do a POP-D on that yet. There we go. All right, so Win32 load renderer needing the DC is the only weird thing there. And you can see what was happening with that here when we do init default renderer and I pass the window, we just called get DC on it. So I guess it's just that, right? Oops. Oh no. Accidentally deleted our C time. Okay. All right, so I think that's all good. And it works. So now the question is, can we get it to reload, right? And so we're gonna have to change the structure a little bit of it because in terms of what we actually call in the renderer, you can see that we've got, so if I jump to that platform renderer structure, you can see that there's like functions in here that you call, and we don't really want those to work this way anymore, right? Because what we're going to do is when we call load, we then want to be able to call like begin frame and end frame every frame. And when we reload, we don't want to call load again, right? So when we're just changing things that happen per frame, we don't want that to actually change things, right? So we need to kind of work out how this is going to happen without there being any weird problems like that. So because we can't reinitialize all of OpenGL. I mean, I guess we could. So, I mean, the problem, right, is that we have a bunch of texture state. And so I guess there's two ways we could do this. One is we could just make it so that the render just gets strobed and it goes. The other way I guess we could do it is just have a call into the asset system that's like clear everything. Right? And then we do just reload the entire renderer. So like we shut down OpenGL and reload OpenGL completely. I mean, the upside to that is, that it's complete. But I don't think I want to do that. And the reason is because if you think about what we'd actually be using this for. So if you think about what we'd actually be using the reloading for it's going to be like changing shaders and stuff, right? And so we don't want to pay the cost of resubmitting all of our textures and all that stuff just to change something in a shader. So we probably want to make that round trip as fast as possible. So my guess is we don't really want to do that. So what we probably want to do is say that like renderer begin frame and end frame, which are the functions we actually call here, we probably just want to migrate those out. So the platform renderer would these, right, would actually move out to here like that. And then these would actually be things you actually get proc address. So they exist external, right? So begin frame and end frame actually get exported. So this stuff here, right, actually gets exported. And so I assume OpenGL loader init, or I don't know. Yeah. So in here, like where it's doing all its whatever the heck it's doing, right? So like in here, for these, Win32 OpenGL begin frame and Win32 OpenGL end frame. So these callbacks like that are happening in here would actually just be called begin frame and end frame, and you would look them up directly. Right? So I think that's what we would do, and this would go away. We would say in here that there's like begin frame and end frame, and maybe these are, since they're the Win32 versions, maybe they look like this. That I guess is what we would go with. So then, if that's actually happening, then we do need one other thing, which is inside the build-up bat. When we say we're going to build this renderer, we need to say that we're exporting these, right? So we can just say that we've got like, Win32 begin frame and Win32 end frame. And Off we go. All right, so that's all well and good and happy and dancy and everyone's, you know, doing their thing. But what we need to do now is make it so that the external code that's actually using these knows to call them not in the render itself. So it can't use that. It's got to use renderer functions, right? So let's make sure that happens. But other than that, I think now it should work by having all of those things loaded. So in here, we're like, actually, it's renderer functions. Actually, it's renderer functions. Actually, it's Frankenstein's monster. And so on. So in this code, which is just the render test code, again, this part here wants to now do a little bit more stuff, right? And maybe this just gets welded in and we just have these pieces of code like right in here. So with the Win32 init default renderer thing that's happening, we would want to just go like this. And what's this called? There we go. Right. So we just want this to load these up. And hopefully that works. Right. Now, this goes away, I think, because that's going to happen here. And I just want to make sure this compiles okay. Limits is got to be passed by address now. And this is just going to be like that. Okay. So I also probably want to make sure this actually works at all. So let's see. And I think that's fine. It's just, right, we don't have any lighting here, but you can see that it's still there. We should probably add some lighting to our renderer test, or at least turn it off. But so that seems fine, right? All good. And then what we want to do is get this one working with reload, because now everything is calling through 4 separate functions, so you can load and then also do begin end frame. So that means we could reload, and it would, in fact, switch which begin and end frame calls were being used. So if we were to do that, we would want to do that, I presume, kind of after the end of a frame or before the beginning of a frame, one or the other. So I'm assuming what we want to do here is say, all right, let's also see, where does that... Where are we actually updating that down here? Here it is. So like here, after we do this stuff, I'm assuming we would just, after we reload the executable, we'd also reload the renderer if we wanted to. Like maybe right there. So right after we end the frame, we'd do something, right? So maybe we'd say like if Win32 check for code change, then Win32 reload code. You know what I'm saying? Just that. And I don't really know. I don't really know what I want to do after that. The settings get like munged. I just need there to be like a strobe that says, hey, it got reloaded. So you're gonna have to reinitialize yourself. And there's like a settings, there's this thing, right? And it's gonna do a diff on these. So we just need like a force reload kind of thing. And I suspect that probably we could just clear the game render settings like this one, and then it would just all look new. So maybe that's the easiest thing to do. I don't know, but that's the next part. So let's just see if this works at all right now, and then we'll kind of try to massage things into place. So if I just change something that I know will create an issue or whatever, right? So like if we run this thing now, and you know the game is doing its thing, and I go into the renderer here, and I say, oops, that's not the renderer. I go into the renderer and I just say, actually, I guess I want this. I want the OpenGL, not, you know, agnostic code. And I say like, oh yeah, like, you know what? Let's just change like the clear color or something. So that like when we do a GL clear here, like we're gonna clear to some other thing. Right, and this is going to be a disaster, right? In theory, I think. Oh. So I guess I'm not sure. I can't see this because my head's behind it, so I guess I'm going to have to do this, which is not what I would prefer. Oh, you know what? I could put it here. That'll work. My head's in the way. So where did we crash? We crashed at address 0. Oh. So actually, I didn't need to do that. So that just means we hit a call into something that didn't actually exist, I guess. Meaning the reload didn't work, right? I guess I should check these here. To prevent that, but that does mean that something broke because it should have gotten addresses for those things. So we did screw something up with the reload that doesn't screw up when you're actually just loading it like normally, right? So let's go ahead and make that happen. So here, you know, we sort of have an issue where, like, you know, if we can't load the renderer, we would need a fatal error, right? So let me go ahead and issue like a fatal error, because if we can't load the renderer, then we can't even display an error message, right? So we would have to rely on the operating system to put up like a dialog box on our behalf, because that's the only thing we could possibly do, right? So I don't know where the error message thing is here, but that's not the one I'm thinking of. I'm talking about the platform error. Win32 error message. So yeah. I'm just going to say I'm unable to load a renderer here. And that's actually renderer code. And then inside the begin frame thing for rendering, we'd also have to do the same thing. I mean, I guess part of the problem here, though, is frame probably gets used elsewhere. Like, where is frame used? Yeah. So, I mean, one of the problems is, like, I guess I'm not sure to what extent we can really run without a renderer. You know what I mean? Like, more or less, this part here probably just has to say, like, okay. I assume all this stuff. So, like, you know, the global pause thing is a little weird because, like, you know, I guess I don't actually know. So let's do it this way. Let's actually just look for where that thing is used. So it's in here. And it's in here. And I guess I don't know. If frame end, can frame end deal with the fact, like maybe frame end has to deal with that fact that it doesn't actually get one of the render commands, right? Yeah. So I guess what I would say is, like, probably we just need to do this. I mean, I really don't know if that's sufficient. It's really not great. I mean, this should probably be rewritten a little bit to support, like, not doing these things, right? So, you know, debug start and debug end. So I guess I can do this. So I guess we can do it like that. So this part here is the only part that this really depends on, and it's a little bit iffy, right? So, you know, we can't initialize the debug state memory if we don't know like what the actual size is there, which is kind of busted. So if you look at the render dim, the relationship of render dim here, it's because it needs to place these things. And that's just kind of stupid. Like that's just, we shouldn't have done that. And I also don't know that we even really need to do it anymore. You know what I mean? So I don't know. Like, I feel like that's just stuff that should be removed. A lot of this stuff should get cleaned up at some point, but you know, it's debug code, so we don't spend a lot of time on it. After it's sort of in there and working, it's like hard to usually make excuses to go make it not be bad. But in terms of these, right, so yeah, it's like render dim width, and we're going half of that backwards to, that's to like the left corner, right, or whatever. And so these, I don't know, like in terms of placing them, I feel like they just want to get placed repeatedly, right? So, you know, who knows what this gets set to here. But basically, like, if we got rid of this, these would be the only things that actually, like, didn't work, right? And so I think what we want to do is just do, like, just stop doing any of that. Like, I don't think any of this is good or necessary. I don't even know if we're using this anymore, but I think we do want like this to go away, right? So we shouldn't have that. And that way in here, we can just say, look, we'll do the debug start and end only if we actually have the ability to draw stuff. And that way we can always continue to the debug collation even when we don't have a renderer, right? Just for hardening purposes. And so now, like, we just have to, oops. What's the problem here? Should probably compile in debug mode so I can see what's going on. So now we just have to, like, actually suss this out a little bit more. But yeah, so we definitely only want the is valid part of the renderer code here. We definitely only want to call these things in those circumstances, and that needs to be there. But then we have to go figure out why it was becoming invalid in the first place, because it shouldn't have. And so we need to go figure out what's going on there. Okay, so in theory, I mean, I would think if we just like recompile now, it should break, right? Because just the act of updating the renderer breaks. And you can see, yeah, we definitely did. And unfortunately, like, I can't get a call stack back here, so I can't actually see where I actually am. So where I'm actually jumping into 0, I don't know. Because since the IP was set to 0, I'm not actually sure. I might be able to still look at it somehow and try to find out where it is. But what I might do is just step into the code at that point and see where we actually go wrong. So what I might do is say, all right, let's go to the code that actually does the reload. Because we're assuming that this is the problem. And let's just see if it is, right? So here's me recompiling, and like, we should get a breakpoint here at some point. Oh, not sure why it didn't let me set a breakpoint there. All right, so we may have to compile in debug mode, I guess. Because it doesn't know, I guess, where that is. All right. So here's compiling a debug. And so in debug mode, hopefully we can get a breakpoint on that particular thing. So I'm going to go ahead and rebuild. And so we've stopped here at Win32 Reload code, which is where I expected it to stop. And I'm just going to step into it here. So you can see the load code attempt, and it thinks it succeeded, right? So it thinks that it actually did load the code. So let's see what it, oops, that was bad. I didn't mean to do that. Well, I can still look at what I wanted to look at. So if we look at renderer code here, then the function table that's actually here, I suppose I should check it this way, does actually have code for each of these. But, so I guess the problem happens further down the line. So let's see where the problem actually happens if I step through the code here. For example, does it happen in begin frame? No. Just keep running down. Does it happen in end frame maybe then? I mean, the next time we call the renderer isn't for a while, right? So presumably none of this fails because it doesn't involve the renderer. How about this? Nope. So then we get down to the end frame call, right? And so it's in there. So it's actually in the OpenGL end frame call. Oop, stop that. So why would that be? And I can just step through that now and find out, I guess. But the question is, why would we be jumping to 0 in here? Like, what are we jumping to? Is there something that we pass here that we jump to? That, like, are we calling any actual programs inside here? Because it doesn't... Are we? Where would we be doing that? I'm gonna have to just step in there because I don't know where we would be jumping to a function pointer in here, unless it's just the OpenGL function table itself. But what that should just remain, like that should just be mapped into our address space and should not have changed, right? I mean, is that wrong? I don't know. So I guess we'll find out. I'm going to go ahead and run again. I will force it to reload. So here's me reloading. And I guess I got rid of the breakpoint that was on the other function there. Wait a minute. That breakpoint is still there. How come it didn't hit? So why isn't it letting me set that breakpoint? I don't understand why it's being so finicky about this breakpoint. Like, why can't I just set this breakpoint? It doesn't like that breakpoint again. Can I set it here? So it just can't set a breakpoint now. It's like, I don't know, man. I wonder why Remedy cannot set a breakpoint. Is this something to do with the currently loaded state of it? Or is it just that the build itself makes it difficult for it to know how to set a breakpoint there or something. So it just can't figure out how to set a breakpoint there, and we don't really know why. But it really doesn't like it. So it's like this file, it's just like, look, I don't know where breakpoints go anymore. Apparently. I need to update my remedy to the new version, so I wonder if I'm actually just hitting a bug. And that's just a bug that's occurring. I'm not sure. That's one I couldn't tell you. Yeah. So I don't know. Something about the PDB and the exe being out of sync there, I guess. Well, it's good enough for now. Let's go ahead and keep going. So now that we break here, I'm going to go drop over to the OpenGL side of things. And I'm going to look at the part where we actually go to the end frame, just so I can see like who is jumping to 0. Like I don't know exactly who that would be. And so I'm going to try to just like run over to that. So no, it did not get there somehow, apparently. Let's try this one more time. Hopefully we still have the breakpoint. No. All right. So I think like we're not super able to actually set these breakpoints here because for whatever reason, when we actually do the rebuild, it looks like this rebuild throws Remedy for a loop. Like the fact that we have the other DLL that we're loading also has the random in it. Unless there's a bug in the way that I'm doing this, like unless this build step is somehow busted, which I don't know, it could be. I don't really know. So yeah, we don't know who is doing that, and we don't have any way of actually stepping into it. I guess we could just use a different debugger temporarily. Is thing one. I could also try to instrument it. So you know what I could do is I could just say, well, okay, so, well, and you know what, I could do this. So we believe that that works. A fresh recompile without Remedy running at the time. And then we could run to that point and then just step, which we do know works. And I'll just step up until the actual breakage point. Right. So there's the reload, right? And now I'm assuming that, like, I can't really, can I? Oh, so I can sort of run to a new breakpoint. So does this actually work? Yes. So here we go into Win32 end frame here. And that's going to call OpenGL end frame, which I guess we don't know. Maybe that doesn't work. I mean, where is that? Let's see. That's not a very good total texture memory number now, is it? And that's completely invalid. So this is not off to a good start. If we're honest about it. so I guess one thing we would say is we got some bugs we can fix right now, even without looking for the rest of this. Since I'm in here now, I'm going to do a little bit more of the looking there, but that's just total garbage. So, yeah, we can take a look at that a little later. All right, so let's take a look at where we're going to call here. So you can see that the call is jumping to a specific address. So that's not going to jump 0 on us. But we do call some pointers immediately after that, right? So I guess we'll see what happens here. So let's see where this goes. Actually, where the heck are we? So in that first call there out to wherever this is calling out to, which this is unable to actually tell us where that is in the source code, that's actually where we fault out. So let's take a closer look at that. And we have to do fresh build here, apparently, right? Let's run to here. I'm gonna pay attention to a couple new things here now, just because I know there's some errors in there. So, one of the things I would like to see is, this is the renderer here. Is this... Okay, so what's going on with this? How is the platform pointer 0? I guess that must just be because it doesn't actually ever need to set that. I also don't know what's up with total texture memory being 0. Do we not track that anymore? Because I thought we were. And no, I guess we're not. So why are we not tracking that anymore? I guess we don't track it anymore because since we use texture arrays, we never count whether or not we use them or something. All right. I should put a to-do in there. All right, so I guess that platform stuff is as expected. And in fact, we have a comment right here that says, like, we don't use it. So it's literally there just for, like, other people who want to write renderers to stick stuff in there. Which makes sense because, like, if you're going to use, like, Direct3D or something or whatever, you probably want to stick a handle in there that's like, here's the Direct3D handle or whatever, right? So it makes sense. All right, so when we reload this code, something weird is happening. And we're not sure what. That is the what. That is the what right there. What is that about? That is just nonsense. That's probably why we were messing up Remedy as well. All right, so let's fix that. Because we basically copied code in there, or I shouldn't say we copied it. We moved code in there and then didn't make it actually generic, right? So this is getting the original DLL name, right? But that name is not, is only, that name means we're going to copy this file potentially on top of an existing DLL that we need to change, right? So this needs to be a unique name, and it can't just be arbitrary, right? And you know, I don't know how exactly we want to deal with that. But if you look at the fact, like, we're putting the temporary DLL name into here, right? We just need some way of this thing having a different name depending on which one of the files it's actually loading, right? And we could just pass in more names for that, but probably the easiest thing to do would be to say, like, when we do the Win32 build exe path file name, so so in here, if we pass one of these uniquing numbers to it, it's going to do one of these things, right? And probably what we want to do there is just have some way that that can also handle, like, sort of some additional uniquing, right? So I guess what I would say is maybe we have a thing in here that's like, nah, you know what? I'm just going to do it. So I'm just going to have this thing actually be stated in there. So if I go to the Win32 loaded code thing, I'm just going to say, like, hey, let's have a, like, that, right? And so we're just going to actually specify those. So when we now go to set the DLL full path and stuff like that, like this, I'm just going to actually put it. And because I was like, well, you know what? I want it to be named right. So we'll say that there's the renderer temp DLL, and then down in the code version, or the game code version rather, we'll set that one so that we can see what they actually are. Hopefully this will also fix our Remedy problem, because now Remedy, because we were like swapping out the files underneath Remedy with wrong files. So I think it was correct to complain, because it's probably like, I don't know what's going on here, man. You know, you're pulling a fast one, and I don't want to deal with it, which is totally fair. All right, so let's try that one more time. So here's, okay, this is a debug build, so it's a little slow. And now I'm going to go ahead and rebuild. No dice. That's unfortunate. So what did I do? I thought I fixed the problem, but I totally didn't. All right, so let's check it a little more carefully. All right. Rebuilding. Should break right here. Here's the reload. So this will just clear that out. Here's the load. That all makes sense. Let's take a look at what this actually builds here. Sorry. So that's not actually good. I mean, it's not horrible, but we actually needed that to put a number in there because we would rather it actually make the unique number. I mean, it doesn't have to. That's still fine. But it's not the best, right? So we should probably initialize those to non-zero. But it's fine. So if we look at this, it's like saying, look, we're going to copy this DLL to this DLL, right? And off it goes. And then we're going to up that number so the next time we reload it, it's going to be different, right? So it wasn't able to copy that. It was able to copy that. For whatever reason. Oh, because it's already loading this one. I guess that's why. So really, this thing should increment either way, right? That is actually forcing it to do one failed copy file for no reason. So I may fix that just while we're in here, because I would never remember to do it again, because it's kind of an arbitrary failure. So basically what we would say is, look, every time we do this, we're going to inc the DLL number, right? And we probably just want it to wrap. So what we probably want to do here is say, look, when we get to the end of this, we would just wrap around to 0. And this part should probably not do it that way, right? So what it should probably do is like say, look, if temp DLL number equals 1024 loaded temp DLL number equals 0, right? And in fact, we could actually just say like, do it that way, right? So up here, then we would say, actually, attempt index equals 0. Attempt index is less than, you know. We're going to try this that many times. And then in here, we're just going to like roll this number over as many times as we want to, right? All right, so that now should be a little bit more sensible. Yeah. Now let's take a look at what fails. We're going to do Win32 reload code now. There's the unload. Here's the reload. We're going to try to copy it to here. That should succeed, and it does. Now we're going to try to load it, right? Now it's loaded. And now, yeah, we still don't really know why that was having such a hard time. And I don't know why. I would like to see whether I was causing that remedy bug. Like, can we now step to this okay and all that stuff? Yeah, we can. So here we are in OpenGL endframe. And so inside GL bind buffer, we actually get, oh, and wow, it's actually at the GL bind buffer call. Okay, all right. Let's say I believe that. Did this fix our remedy issue, by the way? No. All right. So did I still screw something up would be, I guess, the other question I have. Like, because that remedy issue is weirding me out. It could just be remedy has a bug. But it could be that I'm, like, screwing up the PDBs and the code and stuff, right? So I'm a little nervous about that because I don't actually know. And let me look... So here's like some of those temp DLLs, right, that you can see. And maybe if I delete those and we'll just watch which ones are created, because I'd also like to just know, you know, what's happened there, right? So if I wanted to here, right, and just run the game, I'm just curious like what it produces here. So it probably, presumably did these right. I mean, there they are, right? And then when I do the and they are different, like, you know, it didn't like copy one over the other or anything like that. And then when I rebuild, which I'll do now, I'm going to do a dir, and yeah, produce these two. And again, they seem like they're properly sized. If I look at the source DLL, excuse me, if I look at the source DLLs, they do seem to be reasonable, right? So I guess I'm not clear. So there's two things here that I want to know, and I don't really know. You know what I should do, though? I should get a new Dota hero. I forget where that is. I don't know which one I want to go with. Sand Assassin's not bad. An Ogre Lancer is probably pretty good. Some pretty good ones here. All right. Anyway, so assuming that that copy is working properly, so I have two things that are bugging me. The first one is I don't know why Remedy's getting confused about the game's breakpoints, and it's especially weird because the Win32 DLL that is getting rebuilt, though, that didn't get overwritten, right? So I don't know what it's weirded out about there. Like, that should have just still been working, right? There's nothing. I don't see why, because like at the very least, I should be able to set breakpoints here in the Win32 code, because that's not even one of the things that's getting replaced. So that's really weird, and I think that must be a bug in Remedy. I don't know if George is still on. If he thinks it would or wouldn't be, he would know better than I. But I don't know why that's happening. But then the second thing is, like, why are we jumping to an unknown function there? And that question is a little bit weird. And I wonder to what extent, like, is it because we can't reload something that calls OpenGL? Because doing that reloading changes some kind of a state that, I mean, I don't even really know why that would be the case. But let's at least try to verify what's going on there. So if I run and now I rebuild, right? I can still set a breakpoint now, which is weird. I don't know what determines that part of it. It's kind of strange. But if I now jump to the end frame call and step in here, go to OpenGL end frame. So I believe it was a bind buffer call, right? It was this, I want to say. Probably. And I don't know, maybe it's this, maybe all we're seeing here. In fact, now that I think about it, maybe the problem is that we maybe have a global that we don't reinitialize or something like that, in which case we're going to have to go take care of that. But if that's the case, then that's pretty easy. But either way. So here's the OpenGL call or function. It's looking for a vertex buffer, which should be here somewhere, but I, for some reason, can't find it. There it is. So it's just passing 1 to GL bind buffer. Ah, but it's not. Yeah. All right, so this is way easy. Like, this was just me forgetting how this worked. This is a trivial bug. So the problem here is just, we've got a bunch of functions, right? And GL bind buffer, despite looking like a pretty innocuous call, actually is technically not in OpenGL 1. So that's the actual problem, is we just haven't reloaded our GL function table, right? That was local to the DLL, and, you know, it didn't get reloaded. That's all. So in terms of what's happening when we load all of our extension nonsense, right? Like, this stuff we don't have to necessarily care about. But the part where we actually load, like, all of this crap, right? That stuff actually still has to occur. You know what I'm saying to you? And I guess what I would say is, I know it's kind of annoying, but I'm just maybe going to go ahead and say, let's just put those into the OpenGL state itself. I mean, I think that's what I'm going with, right? So let's say that instead of what we were doing before, we just wanted to go in here and say that, you know, this OpenGL thing keeps track of all of our stuff, and we're just going to say that all of the functions go in there. Like, sorry, man, that's just where they go, right? So all of this garbage, right, would have to go in there, and hey, you have to call them anyway, right? So we're just going to say, look, we expect them to be defined, and you're going to have to call them or something, right? And we can use this old system for that probably just fine, right? So in here, we just say, like, OpenGL function, like this, and maybe it just looks like that. And then all of these will be in there, and we're just going to make that work, right? So like in here, we would put those. We're going to have to fix the swap interval one. Will have to be handled specially because I think that's kind of a little saucier. Actually, I suppose I can just replace that. Because no sense in typing it multiple times. So if we do that, then what I can do is just say, like, all right, let's move the rest of these into that. Like so. And this is a little bit boring, but at least now these will be a little more uniform. And No. No. Come back. Here we go. So then here's all our gigantic disaster of 8 billion OpenGL functions that need to get in here. And so we need all of those, and now what we do is we just say, all right, when we were loading those before, now we're going to load them into the actual OpenGL struct so that they'll persist okay. And the problem we're going to have here, I guess, is that we need these to be defined ahead of time, I suppose. And I'm not sure where that actually gets done. Who includes this thing? I don't actually know. Somebody does. So it's actually right there. Oh, so this is actually all fine. So really all we have to do is just change these names to actually conform to the naming convention we have now. So it should be as simple as just doing this. Right? I guess I don't know what some of the capitalizations are on these in OpenGL, but I'll look here. So that's, I guess it's that. But most of these I would know, right? So it's GL bind frame buffer, gen frame buffers, frame buffer texture 2D. Check frame buffer status. Blit frame buffer. Attach shader. Compile shader. Create program. Create shader. I don't know why that is. Why does it think that's a keyword? That doesn't bode well. Probably means we got an error coming down the pipe. Use program get program info log. Kind of amazing that modern day we still have this issue that, you know, none of this stuff ever gets fixed. Like, why am I doing any of this, right? Like, why isn't there just a way to call OpenGL? Who knows? Well, I sort of do know logistically why, meaning I know the corporate politics involved in why, but that's not really an excuse now, is it? That's an explanation of why, but it's not a good reason why. All right. So now I guess we should be able to make all of this stuff work through the OpenGL layer more directly. So when we call stuff, we would pass the OpenGL pointer around, and people would just call through that, which I think should be relatively straightforward. But I guess we'll find out if it's not. But basically, it would just involve you doing this. Right? You know what I'm saying to you? And then, you know, anytime somebody has to call something, they got to do it through here. I'm going to not do that one just yet because I actually don't know how that would work. I mean, I guess we'll find out. I'm not sure if this will create a problem to do it this, so I'm not sure about these GL get string I things, but oops, we'll see. Yeah. Oops. So mostly this just would involve sort of weaving OpenGL in through here, but other than that, the code stays the same. And we could have done this the other way by just calling it again, but I feel like this is a little bit nicer because then at least we can also see. I like the idea of making it visible, like what we're actually storing and calling off of dynamic pointers versus things that are welded into the system. That feels a little nicer to me because I just like it better represents what's actually going on, so it's not trying to hide like that fact. And you can see just when you read the code, you're like, oh, okay, those are like that's all the stuff that's actually coming from dynamic calls into the driver that are not necessarily, you know, even in Windows. Oops, that's not what I wanted. There we go. Yep. I assume both of those need the thing. And this should probably be happening for everybody who makes a program. All right, so this is all pretty boring. Nothing interesting here, really. That has to get threaded. So does that. And almost done, actually. All right. So now we've got to go make it so that the loader is working off of these because it's still thinking it's loading, you know, globals, which it ain't. So this code specifically, right? And one of the nice things about it is we now unified all these, so all of these actually don't have to go this way anymore. All of these can actually be done this way now, right? Which is nice. So this stuff, we can actually just kind of grab these guys and stick them in here, right? And, oops. So that should be nice. And there we go. So now everyone, oops. So now everyone can load that way. And we can change this to just say, well, we know that it's exactly the same thing. It's just off of the OpenGL pointer now. Right? And so that basically takes care of all of our loading. So that loads everything for us now, which is nice and better anyway. So then these right here are also the same. Oops. It's just they're inside the conditional. So I thought this OpenGL get info needed to take the OpenGL pointer now. How come that, right? Yeah. So this should have been doing that. Is there another one somewhere? Yeah, that is totally not true. So there. And so what we should be able to do now is take that code that was previously doing it this way and make this work that way too, right? So there's no reason not to just do these through the same path. And now everything is like actually much nicer to deal with because it all goes through the same macro and everything's relatively uniform. So I think the only thing we have that's really not good is this. Because wiggle swap interval, I don't know where that gets called exactly. We can look and see. So you can see like our vsync would break here in that case. And so what I think I might do is if we look here and we say platform OpenGL setsync or whatever, maybe we would just do like, maybe we would just do platform OpenGL setsync will do the call itself, right? So like the place where we were gonna do it, it wouldn't be in here. Where's the Win32? Here it is. Wiggle swap. Where did you go? Here. So what we might do is like this, because this one's special. So what we might do is we'd say, hey, like if we don't have one, right, then try to get it. And then, you know, off we go. That way, what we could do is say the place where we took that out of, which is here, we can just say, look, we'll initialize to trying to do it, but anytime that we find that we don't have the function, we'll try to get it again. So if anyone calls this, it'll try to look it up again in like a new renderer. And I think that would be sufficient. Not sure. All right, so here's the whole thing. Again, let's see if it works. Running with us updating the OpenGL table in a structure now, so we can just have that around. And then let me rebuild and see what we get now when we hit this code path, right? Just to see what happens. So let me run it and see what what happens crash-wise. So it looks like we're fine. Right, so now it looks like it is reloading the renderer. So that's good. Let's try it in release mode. And see where that's at. So here's it running, and I'm going to go in there and change the clear color thing again. And I guess, like, we should now be able to change whatever we want in the renderer code, and it should actually just work. And then the only thing we have to do, which I'll save for next weekend, is just putting in a thing that strobes it so it recompiles the shaders and stuff. But otherwise, I think that's it. So what would be something I could use to test it? Might be like... so let's do this. I'm going to put in a half width call here. Yep. And then I'm going to rerun that. I'm not sure why that takes so long, but I guess that's just the reloading time. I'm not sure. I have to work on that reload time. It's probably just the compile time, right? It unloads the code and then it's trying to reload the new code, but the compiler hasn't finished outputting it yet. All right. Okay. We'll do a quick Q&A. But that's really all we wanted to get accomplished there. And so now we can reload our render code, our whole renderer, which is nice. A lighting question, but it also has application in meteorology. Do you know of any algorithms to compute shadow or no shadow for all future February 2nds? Or are we simply stuck with the Punxsutawney Phil algorithm, the current but rather limited state of the art? So I don't think that has anything to do with it, though, because isn't like, I mean, I guess I don't know, but doesn't it have to do more with whether it's cloudy or not, or which direction the groundhog faces or anything? Like, I mean, does it really have anything to do with the position of the sun? I don't know. Alex Kelbo says, sorry, I missed it. What did you use TensorFlow for? Oh, nothing. I was just wanted to see how bad it was to build. And the answer is very bad. But we did get it to build, so it wasn't as bad as we were fearing, because we were fearing maybe we wouldn't get to build at all. Valbus, is it not faster to load a shader from a file and change them on the fly when the file is modified? Yeah, it would be faster. Sure. But then, of course, you also can't change any other things, right? So you can't change, like, what actual steps you do in the renderer. So we would like to be able to change everything. Chronos.org says that we should load procs by wiggle get proc address, and if it fails, then load library OpenGL32.dll and get proc address. In which situations is it relevant, or did I miss something? So I guess I've never really experienced a situation where I had to open OpenGL32.dll myself and then call get proc address, but I'm sure there probably is something, but I couldn't say. Would you recommend the OpenGL struct function table for versioned clibs? Can you be more specific about what you mean by versioned clibs? If you wanted to implement stereoscopic 3D, are there OpenGL functions specifically for that, or would you have to do everything manually? So the answer is yes and yes. There are specific OpenGL functions for stereoscopic 3D. They are antiquated and you wouldn't want to use them. What you actually need to do if you want to do stereoscopic 3D nowadays is actually also quite complicated. Because usually if you're talking about stereoscopic 3D, you're usually not talking about rendering two images that are just slightly offset left and right. While you could do that for rendering, maybe like if you're trying to make a hologram or something, maybe that would work. But if you're actually trying to do like virtual reality, then you actually need to apply lens distortions, because the lenses in the headsets of VR systems don't project planar things to your eye. They project sort of a spherically warped image onto your eye. And you need to know the distortion parameters of that image. So you really have to basically have lens data. And you'll note that all VR headsets now report lens data, and that's why you have to render using that lens data. So you need to know the lens data, and then you need to implement shaders that actually like produce images from the correct stereoscopic separation, but then that also will produce warped images. Right? You mentioned there being no standard way to interface with graphics and the politics behind it. Do you see a specific reason why console manufacturers couldn't push hardware vendors for standardization and have that standard bleed out into general computing? Sure. Again, like politically speaking, what is their motivation to do that? Console manufacturers 100% always, never, for any reason, want anyone to be able to use their stuff, right? The whole point of a console is they lock it down completely and don't let anyone access it except people that they allow. So the last thing they're going to do is define a standard and let everyone else use it, so that people who can write games that run really well on a PlayStation 5 can also now write games that run really well on all this other hardware that's the clone of it, right? So that's just not, I don't see that as being politically plausible as a thing that would happen, right? The Eighth Mage says, if it matters, I once implemented a network in C++ from TensorFlow, and it was faster single-threaded by an order of magnitude compared to the 28-core multi-threaded TensorFlow implementation. Yeah, I would like to do that as well. I would love to do that test as well. If you happen to have it lying around, email it to me. We can take a look at it sometime. Is the same OpenGL context being used after render reload? Yes. So OpenGL contexts are not tied to a DLL. They're tied to a thread. So as long as you set your OpenGL context up and make it current to a particular thread, even if you reload completely all of the code that that thread is executing, the context is still there, right? So the only reason we had to reload all the pointers was just because, look, those pointers were in the DLL's data space. So when the DLL got reloaded, it got a fresh set of globals and they were uninitialized, right? So we could have chosen to just reload those in, but I chose to just put them in the struct that sticks around. For APIs, the requirement of being downloads compatible and introducing breaking changes is only allowed in a second API struct. I mean, I guess what I would say is I don't really understand the question exactly or really what we're trying to accomplish. If I had a specific thing in front of me that you were asking about, I could probably tell you the answer, but I'm just not sure what the question is. If what you're asking, generally speaking, is can I use a structure of function pointers to something that changes so that there's code that's going to use this structure, and later on I'm going to update the structure with more to add more stuff or change things, can I still use it? And the answer is, of course you can. Actually, all you do is make the structure longer and put changed versions down at the bottom and rename anything in the upper part to be like deprecated or whatever, right? And then it just works. That's it. And you can version it as many times as you want, and it will just work. Anyone who was calling it in the old school, like in the older version, just gets the first N of the pointers, right? And so the only thing you actually need to make sure that you do is if it's a feed forward system, meaning if you are passing, instead of if it returns you the table, then it just works. If you have to pass the table in and it fills it out, you just need to send the size. Or a version number, and it can figure out the size from that. But that's it. Tomorrow's my first day of work at a AAA company. How do I jump into a huge codebase UE4 that I know very little of? I am a little bit intimidated also by the object-orientedness of the engine. There's a couple things I would say. So the first one is that you have to remember that nobody knows how it works anyway. So one of the things about, modern C++ and large object-oriented codebases is even the people who wrote them have no idea how they work, and you can tell that. Like, people who wrote LLVM screw it up all the time and have no idea what the hell is going on in there, right? And the same is true of UE4, right? So nobody knows actually what's going on in giant code bases like that. And so it's not like a bunch of people are running around with perfect knowledge of everything that's happening in these code bases, and it's just you who doesn't know. It's like, no, none of these people know. It's too big and very obfuscated. So a lot of times, even things they think are happening are wrong, and they have to end up debugging something and go like, oh, crap, yeah, I forgot about the fact that the abstruse template repository factory doesn't produce things in the same memory space as the refunctorer, and so I had to go in and add an adapter class to make sure that it get, and off to the races. So the second thing I would say is remember that all of this modern programming garbage still compiles down to assembly language at the end of the day. It can't do anything at all that isn't just C, right? C++ has literally no features in it, right? There's nothing in C++ that a CPU can do. So all of the ridiculous fanciness is, at the end of the day, just going to produce basically C code. And so all you have to do is start remembering what all this ridiculous garbage actually translates into in terms of actual code functions. And then it becomes much easier because you're like, oh yeah, here's 17 levels of templates and 15 nested class hierarchies. But you know what? It all boils down to a frickin' table call where I just look up in a table and call a function because that's what a CPU does, right? Nothing that a CPU doesn't do can show up in one of these code bases because it runs on the CPU. And there's no objects in a CPU. And there's no templates in a CPU. None of this stuff exists, right? So the key thing to focus on is just, yeah, it's a giant crap load of meaningless text that someone typed into a computer. But at the end of the day, it actually turns into CPU instructions. So just focus on learning what this crap ton of code actually boils down to, which will be quite small at the end of the day. And slowly over time, you're like, oh, okay, all right, I get it. I had to spend like 3 days stepping through thousands and thousands of source lines, but now I get it. This huge pile of templates just creates a for-I loop, right? And it sounds like I'm, making a joke, but I'm not. That you will see that. You will see something where 10,000 lines of code generated one for-I loop that does something relatively straightforward, right? And that's just what you want to remember, because that's what's actually happening. It's one of the reasons that I think it's ridiculous that people say to not teach C or assembly language anymore, because it's ridiculous, because what you're actually teaching them when you teach them C++ or Python or any of these other things is you're teaching them nonsense you made up, right? And maybe some of that nonsense is useful sometimes, but it has nothing to do with a program, right? It doesn't have anything to do with what the computer does. It's all nonsense. It's all just stuff you made up because you thought it was better to type in this set of words than another set of words. But it's not programming. Programming is only things that a CPU can do because it can't do anything else. That's the definition, right? And so it's so crucial to remember that no matter what arbitrary pile of garbage like Swift or Python or TensorFlow or anything else someone dumps in your lap, at the end of the day, it's just assembly language at the end of it. So if you can just focus on what does this huge pile of garbage that a lousy programmer wrote who doesn't know what they're doing, what loop did they actually create at the end of it? Because that's all it can do. And once you can find out what that's doing, then you can kind of reverse back through their disgusting garbage pile to figure out what you actually need to change to make the loop do the thing you want it to do. Now, it would be great if those people had ever gone to a Mike Acton lecture and realized that if they just wrote the stupid loop to begin with, they would have saved 3 months of work and anyone could read it. But they didn't, so here we are. Have I heard of IPFS? No. I don't know what that stands for. Is it Internet Protocol File System? Or something? Yeah, it's very important that I don't spend much time looking at large C++ code bases because interplanetary file system. It's a decentralized file system which is hash-based mapping on the nodes of the network for file lookup. Does that work, though? So why would that fix anything, though? I guess I'd have to go look. So I'll say one thing about that, and maybe they have an idea about what they're doing that would be relevant here, but my first thought on that is well, okay, so let's suppose that what you decided to do was we're just going to take every piece of content at some kind of block, at some kind of blocking level. So we're like, I don't know, based like a file per file, traditional file or something. I mean, who knows what it's going to be, but like we decided to take all the data and we block it up into chunks, and we're saying we're going to like identify these chunks by the hash of the content of the chunk. And that way, anytime someone says like you need this thing, you can just say, okay, here's the chunk that I needed or whatever, right? And so, you know, that's the kind of thing that someone who hasn't thought about the problem very long probably thinks about, I guess. Or maybe the answer is someone who knows way more about than I do, figures out some reasons why that would actually work. But like in my head, I'm like, well, that doesn't work at all, because the entire point of modern, you know, network traffic security is that you can't have anyone know what it is you were asking for, right? So for example, if you take an HTTP request, then sure, that transfer makes perfect sense. If everyone was communicating via HTTP, then you would say, well, rather than communicating by HTTP with an URL, why don't you just communicate by this new thing like IPFS, and we just say, here is the hash that I was looking for, and anyone can respond, right? Anyone who's got it will just hand it back to me. But that's not how the world works now. The world, everything works by HTTPS, which means that you can never have anybody besides the person who owns the thing actually know what you were asking for, right? So I guess I don't understand what that means. Like, asking who has the file that digested this hash, you can never do that. Because if you ask that question, you've already broken your security model. So what's their solution to that? How do I ask for a thing without anyone knowing what the thing is? By hash. You see who I'm going with? And, you know, I can go read about it, but that'd be what I want to know, right? Like, how do they solve that problem? And maybe they've totally solved that, in which case that's cool, right? Because it seems like that'd be useful, maybe. I don't know. I could bring it up here. Someone posted a link. IPFS. Oops. Oh, no. So, I mean, yeah, like, again, maybe this is just high level, but this is just exactly what I just said, and no, that doesn't work. Right? I mean, it doesn't work. Because basically everyone in this network now knows what everyone's doing. So it's like, hey, yeah, you know that, you know, porn you were watching? Well, now everybody in the entire network knows what it was. Because everyone saw you asking for that hash, and they know what that hash is, right? I mean, it doesn't work, even for basic stuff, let alone once we start talking about asking for actual, like, things that's, you know, important, right? I mean, I guess you could argue that people don't care because they know that you're watching the porn anyway, right? But I'm just saying, there's no way that works. Like, this doesn't work. So maybe there's more to it than this is like the thing for, you know, this is how IPFS works for dummies, right? They're just trying to explain it. So maybe it actually has something smarter than that. But if this is literally what they're doing, it doesn't work. So no, not a solution, right? Take a look at the white paper. Where's the white paper? Here it is. Let's see. Do. I mean, yeah, again, I don't see it, right? I mean, it says right here you're sending everybody everything you're doing, right? So like literally everything you browse, everyone in the network knows your entire web history, right? I mean, that's this, right? I mean, not everybody because different people see different parts of it, right? But anyone who's pretty aggressive could probably find out quite a bit. And I mean, again, there's not even a section in here that talks about that. Like, you would want, this should have a thing that's like security. And it doesn't, which is not great, right? So I'm pretty sure this just isn't useful. Like, it's probably fine for BitTorrent. Like, if all you're doing is trying to trade, like, pirated movies or whatever, then hey, like, you're only on there if you're breaking the law anyway. So who cares if people find out about it because that's all it's used for. So all they need to know is, are you using it at all? Well, you're probably stealing something, right? But if the idea is we would try to use this as a backbone for the internet, no, that does not work. This is not tractable. And I don't see anything in here that suggests that they've solved the problem, unless I'm missing it, right? Like, am I missing something? Yeah, exactly. So Ginger Bill, I think they are not trying to solve this problem, which is why I say when people are asking me if this is useful in trying to rebuild the internet, like, no, it's not. This is like a very specific thing for solving a very specific problem. It doesn't help fix the internet at all. Like, it helps make a better BitTorrent probably, but BitTorrent is not the backbone of the internet for a very good reason, because it can't be, right? I think no single node in the network has 100% of a file, so you can only request an incomplete fragment, which will make it harder for the node hosting to guess what it is. I mean, why? Because all you have to do is figure out roughly, let me put it this way. First of all, no, that's obviously not true. Because if you can watch your porn video, at some point you got 100% of it, right? If you could watch the whole thing. If you wanted to steal your pirate copy of Avengers 17, everything explodes or whatever, then you had to get the whole thing. So now you know all of the chunks that were in there. And anytime anyone asks you for one, you know that's what they're looking for. So done, right? It's so simple. Like I could make a node that did that tomorrow just looking at this thing. It's not like some super elite hacksaw job. It's just, that's it. If you can watch something, you can get the whole thing. If you can get the whole thing, you know everyone else who's asking for any of it at that point. I mean, at least in your general vicinity, like anyone who ever sends you a packet. And anyone who wanted to police this sort of thing has a pretty easy time. They just flood this system with thousands of servers that they rent on AWS, and they collect every single thing that everyone asked for from them, right? So I'm pretty sure this just isn't relevant. This is just like, hey, let's make a better BitTorrent, which totally worth doing, has nothing to do with fixing the internet. Like, will not really have any effect on it, right? I mean, hey, maybe it can replace Dropbox, which would be great because Dropbox is stupid, right? But like, no, not helpful on the internet scale. Internationalizationalist. Do you know some good resources that explain how the internet works? You said that it cannot be used as a background internet, but I don't understand why. So again, I was trying to explain the reason why. The reason why is just because when you have machines talking to each other and you start to use them in a peer-to-peer fashion. So, you know, when I need to get, so right now, when I go to ask for something, so if I want to get a video from Netflix, right? I send a web request to Netflix. Now, everyone on the network who happens to be in between, right, who's passing those packets along to Netflix eventually, which I think is actually Amazon, but that's a separate thing, can see one and only one thing. And that is the IP address of the machine I was asking, right? Because everything else about the request is encrypted via HTTPS. So they don't even know what resource I was asking for. So as long as I'm asking for the resource from a site that has sufficiently many resources, no one knows what I'm actually looking at, right? So you don't know whether I'm watching a super sweet, awesome film like Ernest Goes to Jail, or whether I'm watching, like, you know, Scenes from a Marriage by Ingmar Bergman, right? So I can lie to you and tell you I only watch sophisticated movies and that the thing that I'm streaming, you know, is extremely sophisticated and relevant to film history, right? Like I only watch Nosferatu and I watch it 24 hours a day. But actually it turns out that the entire time I was just, you know, watching cartoons, right? And you have no way of knowing. The only thing you know that I was talking to a Netflix server. And you may not even know that if you can't quite figure out what the Netflix servers are, but you probably can because you can just keep asking where Netflix is and it'll keep sending you IP addresses and you can probably cover like most of what they are, right? So the problem with the thing that we were pointing out there is that thing, and people have prevented this before. Vince Cerf proposed it long ago. He said, what if we just looked up data by hash? The problem with it is that once you convert data into hashes as their names, now the way you ask for something, and when you ask, you can ask multiple people just around you and say, hey, did you happen to ever get this part of this file? Because I need it, right? This massively improves distribution because it means anyone can answer any question now. Because if anyone ever got part of the Saturday morning cartoon from Netflix, they know that I'm looking for that now. When I ask them, they can just send it right back and we never have to ask Netflix for it. That's nice, but the problem is now everyone knows what I'm asking for. It's not just between me and Netflix. Now it's me and everybody else who I happen to ask, right? So basically all of the like problems that you get with privacy get greatly exacerbated in a hash-based system, because now all of the peer-to-peer, it's not really hash-based, it's just the peer-to-peer nature of it, right? The fact that I can ask anyone and those people who have parts of the file can just give it to me improves the reliability and speed of the content delivery, but it completely obliterates any privacy that you had. All right, I'm going to close it down. Thank you, everyone, for joining me for the episode of Handmade Hero. It's been a pleasure coding with you, as always. If you would like to follow the series at home, you can always pre-order the game on handmadehero.org, and it comes with a source code, so you can follow along with it. I also am working on a few courses that are going to go up here that you can buy later, but they're not quite up yet. I'll have some more information about that a little bit later on, maybe next month. But I'm hoping that there'll also be some good course material that you can get on here. So stay tuned for that. It should be coming a little bit later on. All right, that's it for today. I'll be back here next week, I believe, when we will go ahead and start working on the lighting using the rendering reloading we just did. And that should allow us to have a little bit faster turnaround times there, which would be nice. All right, that's it for today. Have fun programming, everyone. And I'll see you on the internet. Take it easy, everybody.